Buddy, I hope that you're doing well. Let me start the music so that we can start talking. So, how are you doing today? So, welcome again to another expert call, and I can tell you, you're gonna love it, right? Because what do we know? Well, we know it's with the pressing concern around climate change and energy security globally. We definitely need to address it one way or another, right? And today, we know that the renewable energy transition continue gaining momentum. This is something that nobody can dispute anymore. It's a fact. It's a fact of life, right? And then what we do, we know that we have promising clean energy sources like solar, like wind, like geothermal, but wave energy, we don't talk enough about it. And this is what I want to address today. And I want to change it today, and I want to bring to you a special guest. So he's the chief commercial officer of a very promising company, Wave Piston. Have you heard about them? If not, this is the time now for you to get to know who they are. It's one of the most innovative startup, harnessing the power of the ocean waves. And they're not just a company that have with a technology that is promising, but they also have tremendous potential economic and environmental attributes that you will actually love compared to maybe fossil fuel, you know. And I want you to welcome here our very dear guest, Mr. Emil Schatz. So, Emil, can you hear me?
Yes, I can hear you, Tony.
So, how
Thank
are you
you.
this morning?
I'm very good. I'm very good.
Yeah, you
It's
can see I've already brought the wave for you, so I'm hoping that you're gonna make me serve.
yeah, out here it's snowing.
Oh,
So
it's snowing. Okay. We may want
yeah,
to check that. We start, it's not exactly the same thing. Excellent. Well, I was very excited to bring you on board today to talk about your fantastic technology. You're gonna tell us a lot more about it. But before we dive into that, I think it just makes sense because I'm sure still enough people don't know about the company, about you. I just want to give you the opportunity to introduce who you are and what Wave Piston is. So, am I just making this up, or really you have something that is very innovative and very promising?
luckily you're not making it up. First of all, Tony, thank you for allowing me this opportunity. And that on the day that COP28 is starting in Dubai, that's an extra specialty. Um, my name is Emil Schut. I'm the CCO at Wave Piston. We are a still small company in Denmark, and also we have a subsidiary in Spain. We um, develop technology that harvests the energy of the waves and converts that into electricity and desalinated water. We're 12 people at the moment. We started our business in 2014. The three founders, which are still a part of the company. And we are at this moment, my colleagues are in Gran Canaria at the moment, installing our full-scale installation off the coast of Las Palmas. So very exciting, and we get not today, but we get to see webcams sometimes of what's going on in these days, and that's very exciting to be a part of that.
Excellent. Thank you very much for that. And I know you have a fantastic presentation that you have prepared for us and also an animation. Please stay with us. Oh, by the way, also, let me say that obviously the whole idea of having this conversation is for you not only to discover Wave Piston and what is the fantastic technology that they have in here, but I also want you to be curious and ask questions because Emil is here to share as much information as he can. Obviously, some of it is confidential. Obviously, he can't maybe share that, but I'm sure if he's in a position to give you a little bit more insight about what they're doing, he will be doing so. So please don't be shy and ask question to me. I know at times you tend to more than often send questions to myself and for me to transcribe. I can do that this way, but feel free to directly ask your question as well. And who knows, if one of you also want to join the call, I can give you the link. You can you can join that. But before we dive into the conversation, the presentation, so just a very brief question. You rightly said so. COP28 is starting today, yeah, and we know that we want to triple renewables energy by 2030. That's clearly what is going to be one of the key commitment. I believe I've heard that we're going to go for. But I said that in my introduction, we're talking more about solar, wind, hydro. That's great, no problem with that. not enough about wave power. So, what are some of the obstacles you believe that you have to overcome to commercialize wave energy, across the world? What would you say?
Yeah, it's a very good question. We let's say one of the things that we have experienced and we have learned over the years is that when you start to do things offshore, it becomes difficult. It becomes quite complex. It becomes very expensive, and making something that can withstand the forces of the seas is no easy thing. So it needs to be very durable. What you build, it needs to survive harsh conditions and millions of cycles in a salt water, so corrosive environment. So it's very important that and that counts for all of us in this sector, that you make something that is durable, that it can survive, but also that it's efficient. Making something very strong often means making something very heavy, and
Mm-hmm.
making something very heavy often reduces the efficiency. So combining durability, survivability, and efficiency, and doing that in a competitive cost, that's the biggest challenge. And that's where all of us in the sector have put our focus and our emphasis on getting that to work. And
Excellent. So,
and
thank
and
you.
doing that, sorry to the last
That's
thing,
okay.
what I said about offshore, that
Mm-hmm.
it's complex, also makes it's a very expensive business. And that's what we experience here now with our installation in Gran Canaria, renting vessels, having, if needed, divers
Mm-hmm.
on site. It requires a lot of capital to get through those stages of development.
Yeah. Thanks very much for that. I was just simply going to say you're absolutely right when you talk about the offshore, because when I actually started my career coming from automotive, because I used to be an automotive engineer, even if now automotive is going all green, fortunately, I was actually more looking at offshore wind. That was actually in the UK, in Scotland. That was my primary interest before I dive into solar and so on and so forth, and also focusing more into Africa. So you're absolutely right. So anything that's offshore, so it's another magnitude that's significantly higher than what people do. So that's what could definitely can potentially slow down the opportunity. And I also had the opportunity to work on a tidal project, but we can look at that later. But what I would like to invite you to do today, I think, because I'm really excited for you to share this presentation and also this animation, guys. Please stay around, because I think there's a very cool animation. You could see how the system looked like, and I can promise you, when I saw that, was just I was blown away because how easy and simple it is, yet very innovative. So, Emil, can you just please share the presentation? I'm just going to be on the background, and you go through that and take people through what it is. Yeah. So we're going to have a 10-15 minute presentation, but after that we can come back and take questions. And people watching, as I say, please ask questions, and then be more than happy to address that. So here is the presentation.
Yeah. Good. Well, thanks once again. We're Wave Piston, and we are on a journey to bring wave energy to the world. As you also highlighted, Tony, in your introduction, um, global power demand is increasing rapidly, and it's expected to triple by 2050. We have large economies that are developing. India surpassed China in population numbers this year. All around the world, there's a growing need in power supply. And that also goes hand in hand with the fact that we need to phase out fossil fuels and expand renewable energy, and expand the portfolio of renewable energy resources that we bring into the market. It is expected by 2030 that renewables will surpass fossil fuels, and let's hope that COP28 can contribute to legislation in speeding up these processes and advance renewable power sources in the coming years. And as you can see, renewables as they stand today, they need to grow by 8 times by 2050 to be able to fulfill the demand that is needed. And for some, that will mean like wave energy, which is not commercially available just yet. That will be a significant increase of supply. Here, this is just a summary of several studies that have shown these tripling numbers. As you said it, we have renewables. We love wind. Also at Wave Piston, we love wind. We love solar. They're great. We need more of them, as much as possible, but it's not enough. First of all, there's times when the sun is not shining and the wind is not blowing. In that regard, wave can be very much complementary to wind and solar, but also in terms of available space, available land space, just using wind and solar isn't enough. We need to move out to sea, as is also the development of offshore wind and the technology innovation going on in the offshore solar. Why is wind so much needed, and what can it give? It's a complementary asset to wind and solar wave energy. A recent study, the Evolve project, has indicated that the projects focused on the UK, on Ireland, and on Portugal, and it showed that if you add 10 gigawatts of wave energy to the UK market, you can lower the total cost of energy by a number close to £1.5 billion. And at the same time, wave energy can get prices up to 2.2 higher than wind as a wholesale price because of time-wise shifted production. And I can show you some of the benefits of wave energy in the next slide, and they underline why wave energy is a good complementary resource to wind and solar. First of all, it's highly predictable. When the wind is blowing, it generates waves. And when the wind dies out, the waves will continue to roll for at least several hours after that. So it's easy to predict when waves exist, and thereby it also allows for premium fees to be captured. It's time-wise shifted. When the wind stops, the waves keep rolling, and obviously there's no day and night difference. So the waves are pretty much always available. It's globally available all around the world. There's plenty of areas connected to big oceans, large sea areas, also a relative small sea as the North Sea between Northwest Europe and UK is still a good location for wave energy. And lastly, it has limited land use and it's unobtrusive. And that counts not only for us, but for a lot of our competitors / colleagues in the sector. Everything is offshore. For most, there's only a cable going on land. For us, it's a pipe, as we use hydraulics and no electricity. It's unobtrusive, meaning that when you stand on the shoreline looking at the sea, you don't see the devices, or you would maybe see maximum just the tip of the devices at sea. It's another great benefit of wave, and that also counts for tidal energy, actually. Sorry, I skipped one too much. Okay, how do we get there? How do we get wave energy on the map? Leading up to COP28, there just came a new report from Ocean Energy Systems, where they've given a roadmap for wave energy. And that roadmap is very much in line with other studies and other comments that have been made in recent years about this field of technology. Adding 300 gigawatt of ocean energy would create 680,000 jobs. It would create a gross value added of 340 billion US dollar, and it would even reduce CO2 by 500 million tons. So there's a lot of benefits to gain from adding ocean energy to the portfolio of renewable energy. How do we do that, or how can we do that? We can do that by creating a market pool. That means supporting the feed-in tariffs. UK is an excellent example about this. They have contracts for difference for the last few years. In their contracts for difference, they allow different technologies to get different prices. An example is that Tidal in the latest bidding round has a price of 260 pounds per megawatt hour, and thereby the contracts for difference allows for different maturities of different technologies, and thereby giving them the price they deserve. Another one is creating a technology push. That's for companies like ourselves, helping us to grow our business, helping us to develop our technology, support programs. We're a European-based company, so we use a Horizon Europe program. We use Danish programs. We use the Spanish programs. We can get all kinds of programs to develop our technology further and further and keep on funding that technology roadmap, which is, as you also highlighted in your question, Tony, that's a very important part, as it's such an expensive business to keep developing the technology. Thirdly, they recommend to focus on ocean energy infrastructure requirements, very much focused on port facilities, vessel access, cranes. A lot of our technologies is built close to the water, needs space onshore to pre-assembly the devices, to put them on the vessels, to load them off to the water or tow them off, depending on the technology. Creating ports, creating infrastructure at the waterfront where these kind of technologies can either be assembled, pre-assembled, installed, and then shipped out to the final installation site is a very important aspect. And lastly, regulation and legislation. Energy projects can take up several years. 8 years is not uncommon. A lot of that is about consenting, is about permitting. Which locations are we allowed to use? And you could think of areas where governments take the first step, do environmental studies on their nearshore areas, and dedicate areas and say, okay, it's these areas where we want offshore renewables to be deployed, making sure there's a framework for legislation and there's a framework for especially all the permitting, as that's a very heavy process. These are some of the areas how we can support wave energy becoming a real thing. Then I want to focus on islands and remote coastal communities. They're a special interest group. They're our first target market when we talk about wave piston. The reason being they're highly dependent on fossil fuels and all the dilemmas that come with it, the logistical challenges, oil price fluctuations. So they all the environmental challenges that come with fossil fuel generated power generation, and they lack fresh water. And often they're relying on fishing, sailing, tourism kind of industries to be capable of existing. In those places, wind and solar is already used, is being deployed, and it's great, and more would be better, but it's not enough. And when land space is a problem, then solar PV can also have its limitations. So wave energy can be an excellent opportunity to increase the energy autonomy of islands and remote coastal communities. Then a little bit more about us, about Wave Piston. There's many companies that provide wave energy devices. We think we're unique because of the way we are set up, and I want to show you that also in the animation that's coming up. But firstly, our device can provide renewable energy and fresh water, and that we can do both, it makes us already quite unique. We have a low-tech, modular, and low-weight system. We have the lowest weight per effect, so the lowest tonnage per megawatt produced in the sector. We're unobtrusive onshore and offshore. Obviously, we take up some space in the water, but we don't have any. We have a relative light mooring system, and we have a small substation on land where we convert high pressure seawater into electricity or into desalination. We have no toxic materials in the water. We have no lubricants in the water. No, it's all, everything that's in the water is a passive system, basically handling itself. And the technology part is on land in a small conversion station. Lastly, but not unimportant, we have a high local involvement. A lot of our system is devised of components coming from the offshore industry. The oil industry provides parts. We use a lot of standard components because we know they're highly available. We know they have been tested in harsh environments, making them reliable and easy to replace if that is needed. So we want local involvement when we install systems, but especially also after the installation in the operation and maintenance. We want as much as possible that it's local workforce that contributes to that. And now, Tony, I think the next one would be my animation slide to show you how the system actually works. As you can already see here, it's a string in the water which has energy collectors. That's the sails with the numbers, as you see. So I don't know, Tony, if you can pull it up, or yeah, it's coming now. Here you can see the system in action. It's submerged, so it's slightly below the water surface. Just to give you an impression of the scale, these vertical plates, as you see, are 4 meters high and about 9 meters long, so 4 by 9 meters. And when the waves roll by, these plates move backwards and forwards on the string. Each plate, or sail as we call them, is connected to pumps, and the pumps suck in the seawater and pressurize the seawater via that common string. The pressurized seawater is led via a riser hose and a common export pipe to a station on shore. That's our substation. And there we can do two things. On the right side, you can see our Pelton turbines where we can convert to electricity. And on the left side, you can see a desalination via reverse osmosis. We can do one thing, we can do the other. So we can do one, the other, or both at the same time. And that was it for Wave Piston, or for my presentation, at least in the slides that I've added. And we're looking for, we're developing projects at the moment in Gran Canaria, in Martinique. We're in the early stages of Barbados, and trying to push our technology out to the world. I can see that there are
Excellent.
some questions.
Yeah, excellent. That was fantastic. So I think the animation definitely was very interesting. So let me put. I have had a couple of questions. I have questions for you, obviously, but I have seen some questions. So if you don't mind, we're just gonna prioritize questions that we've seen from people. Yeah. So if I just gonna remove the presentation for now, we can always bring that up if needed. But let me go through some of the questions, and I'm just going to I just want to thank first of all the people that ask questions. Keep asking questions, guys. We still have another 20 minutes or so discussion. So if you really want to, yeah. And the first question that I have, it's something I've received. I also had. Let me just thank Deji. Deji is the courageous man, so he didn't need to send it to me. So he sent it directly. So we're gonna get your question, Deji. That's for sure. But let me just ask the question that the first one that we received. So you could see that email, so that it's obviously coming on your on the screen here. So how scalable is your technology, and could wave farm ultimately generate gigawatt of power? Very good question.
Uh, yes. Yes to the last question. It can ultimately generate gigawatts of power. It is very scalable. And now I'm talking about our technology primarily, because I don't want to talk on behalf of the others. But our system is built for larger energy farms. So we are not an energy provider to, let's say, one measurement instrument out sea or an oil rig. There's others that focus on that market. We focus on definitely the megawatt energy farms. We're starting right now in the first projects with only 2 megawatts. But in those projects, we are already discussing the next phase where we go to maybe 20 megawatt or 12 megawatt. But in our long-term vision, we definitely see, several hundreds of megawatts up to gigawatts of power being possible. Of course, it's very dependent also on the sea area that is available, the space that is available.
Excellent. Thank you very much for that. That's a great straight answer. So second one that I have, so it's going to come in a minute. Wait. Okay, here. So which global region seems most ripe for early adoption of wave energy technology? And I guess as well, let me add a couple. Let me add a follow-up question to that. Which global region as well is, yes, more suitable for wave, but also more specifically to your technology? Would you say?
Yeah, another good question. Well, first of all, there's a wave climate, and the wave climate for our device is attractive all around the world. Of course, there is more attractive and less attractive locations. From what we have analyzed so far, we can see that what is it called? Southwest Australia, for example, around Perth, we expect to have the highest efficiency of the system, so the most power output. We are currently deploying in Plocan, which is in our world, I wouldn't want to call it a bad location, but it's an okay location to deploy. But it's our first system, so it has reasonably high waves, but it's definitely not the best climate for wave energy. The next projects we're looking at is Martinique and Barbados. There we're already talking about a much better wave climate. High waves, short waves are good for our system, and they can be found all around the world in different locations. But what makes it a region that is ripe for early adoption is more than just the wave climate. That also means that there's political backup, that the local politicians want to invest in renewable energies and want to look into and make it possible that wave energy devices are getting deployed offshore. So our focus here and now, and that also has to do with the fact that we're based in Europe and can get a lot of funding from Europe. So we're focusing on European connected countries to start with, Therefore, we are in Gran Canaria. Therefore, we are also in Martinique, as that's part of French overseas territories. And we're looking at US and Caribbean market to start with, because there's a lot of legislation going into the direction that makes it possible to deploy. That doesn't mean that in other locations it's not favorable, but we haven't analyzed every market, every country yet, simply because we don't have the resources. So a country or a region that is good is not only where there's a good wave climate, but also where there's a willingness to be an early adapter from politicians, where there's money from investors, and that can be potentially everywhere, but we focus primarily on Europe and US to start with, and Caribbean as well. I hope that answers the
Okay.
question.
I think you answered that very well. So I have two other questions that I've seen. I think there's two that are not showing up on my system. I had to go and put it up from LinkedIn, but I'm just gonna put it back there. But one that is showing here, and is so my apologies. It's more than Deji just asking. It's just that the other two guys, for whatever reason, I can't see that here, but I was able to take from LinkedIn. But Deji's asking, and I know you covered that, but it's good maybe to come back to that for some people that may have missed that information. And it's a valid question, right? So what is really the competitive advantage that you have compared to the others? I know you said that they are colleagues, and that rightly say so, the colleagues, but at the same time as well, they are competitors. That's normal. That's any market environment. So, what is let's say, the specific advantage? Why people listening to you? So, in the continent of Africa, so in Europe, all other places, the thing is in a way we don't yet have, let's say, a dominant technology like we have, for example, for wind and solar that has established itself. So why would they believe that you are the one
Yeah.
as opposed to, for example, to the other? That's essentially what they're saying here.
Well, there's a few things. First of all, we can generate electricity and desalinate water at the same time, and that, let's say, there's not many that can do that. So thereby we are already getting ourselves in a unique position. And that also means the way we can do that is because we work with hydraulics, high pressure seawater. We don't work with electricity out at sea, where a lot of the devices, they have use a lot of very exciting but also very complex technology to use the buoyancy, the movement up and down, to generate electricity already in the buoy at sea and then convert the electricity to land. That means that they are very complex on the inside, where we differentiate ourselves and say we don't want that complexity in the harsh environment at sea. We want it as simple as possible. And we are very much a lightweight system. As you've seen in the animation, we have different sails on one structure. And by having all those sails on a single structure, we can cancel out the forces on the system. So our mooring, what keeps the system in place, is significantly lighter than if we would have one energy collector, one sail, and have to moor each of those. So we can reduce our mooring by 1/10 compared to what we do if we would moor each of them individually. So making us so light means less material, means also lower cost, and also lower CO2 impact in the end by using less materials.
Excellent. So, anything else, or
No,
that was it?
go ahead.
Okay, good. So let me just ask another question. So I don't know whether you'll be able to answer that, but do your best. So that was asked by Andrew Karuga. So Andrew, I think I should have added your name here. It's yeah, he wanted to know what is the cost per kilowatt. How does it compare to other tech? How does it compare? You just answer that. So what is the cost? Obviously, that would be quite tricky, confidential information. But is there anything that you can say around it?
No, but it's often a question we don't like to answer just yet, because what we do today is very expensive, but it's because it's very low volumes in terms of production. So we predict, based on the economies of scale, based on our technology development, that we can reach, and now I'm talking euros, I don't know where everybody's from, but we can reach levels of below 40 euros per megawatt hour. But that is when we talk, when we are deploying large scale systems, we are utility scale, where we have big agreements with manufacturers, where we are capable of producing to a low price. Because if you look at the systems today, they are handmade, uh, single devices. So what we know it will cost today is not a projection of what the commercial system will do. So we're on that declining scale of getting the price down. We believe we can get below 40 euros per megawatt hour. Um,
Mhm.
it depends on let's say also the partners we can get and the funding and how quick we can get there. But there's a plan to get there.
Excellent. At least there is a response to these questions. So next one, that was Orodayo. Say great work and kudos to the design team. The LCA is a concern. I'm not sure what the LCA is, but maybe you will know from your side email. And the cost of disposal at the end of life. As we know, the world still has a problem of what to do with the blades from wind farm. Is there any plan? That's a great comment. So, is there any plan for recycling it? Yeah.
Yeah, well, and another good question. It's important that we take this into consideration now. So in our design, in our technology roadmap, we look at which materials for the unique components that are ours, because we have, of course, our own IP and technology in there, or components in there. There we look at not only what is cheap, but also what is durable. And if it's more expensive and more durable, that could still be a good business case. So we need to look at in the design not only what does it cost today, but what does it cost during the 20 years it needs to be out at the water, and also how do we can get it out of the water and what will be remaining. So I cannot give a conclusive answer on that, but we're looking into that. We have LCA calculations on our system as it is today. We have LCA calculations on how we expect the system to look at in the commercial version, but we are very much developing that part, taking into consideration, well, it's great if it's cheap now, but if it's going to be expensive in 20 years, then we might need to change direction. Then it's better that we take something that is expensive now, but either holds better or is better to recycle. So that is a balancing act between um, yeah, what we learn of materials, and that's also an ongoing development, not only in our sector but in every sector. So this is a part of our technology roadmap, is finding out what materials can we yeah, do not harm the environment and have the lowest impact in the end over the whole period of the system.
Hmm. Excellent. So, just a couple of questions before we wrap up. I know time is flying, but the next question is: are there useful synergies with offshore wind, tidal, or other renewable technology when deploying together?
Yes, there's a lot of synergies, and that means, first of all, offshore wind is the most developed out of the ones that are here, and is also the one with the biggest traction. They have vessels, they have infrastructure, they have big companies supporting them in deploying these kind of devices. So already there is big synergies. We would love to work with those that are now working in the offshore wind business. The problem is often that they're too busy with offshore wind. So we need to find the ones that are eager to be the first mover in this. But not only in getting the right partnerships, it's also when the infrastructure is there. To give an example about the North Sea between Denmark and the UK, there's a lot of offshore wind, and that is fixed bottom. There's a lot of areas already dedicated to offshore wind. Renewables like wave energy can easily be positioned between offshore windmills. There's no problem in sharing that location, because it is already a location which is not allowed for fishing. It's not allowed for commercial vessels to sail through. So you can share the value chain. You can share the areas offshore. There's probably also a lot of infrastructure to be shared in terms of cabling to land, etc., etc. And as I pointed out in the start of my presentation, wave energy is complementary to wind and solar. So it could reduce the overall cost of an offshore renewable energy farm, because you would have less need for batteries and storage, etc.
Excellent. Thank you very much. So let me ask one last question that's coming from me. So if you could project yourself, 5, 10 years into the future, right? So that means 2030 and beyond. Yeah. So what role do you envisage, wave power will be playing in the global renewable energy mix? What is your take on that?
We believe that wave energy will have a major role in the renewables, and that it will be just as much as wind as solar that we talk about ocean energy being wave energy and tidal energy. In 10 years time, also going back to the earlier question, we believe that we can install utility scale projects, so 200, 500 megawatt projects, being a major contributor to the renewable energy mix. So that's how we envision the future.
Excellent. So thank you very much for that. So I just want to give you a little short challenge, right? Which is because it's COP28, and as you say, starting today. So a lot of leaders, very important people will congregate in Dubai to make sure that we ride the ship, right, and we correct the path into what we're into. So let's imagine they are listening to you right now. You never know, right? There's some people who are listening, yeah? They're listening to you. What would be your pitch to make a central place for wave power? I'm just going to give you 1 minute to do that, and I'm just going to give you the whole screen
A
for that.
central
So
place.
just 1 minute.
Sorry, to get your question right. A central place. What do you mean?
Yeah. So basically, what you want, because at the moment wave power is still a little bit ignored. Let's put it that way, right? But you've been demonstrating that there is a strong potential that come with it, and it should be given its right place.
Okay, good.
In the concept of solution there. I'm just saying that COP28 has started. You speaking to those leaders and all those very important people. What do you have to say to basically to convince them to look at wave energy and also to invest into the sector, and why not also in your solution? So what would you say? That's why I want to give you 1 minute for that. Yeah.
Thank you.
Yeah. I know it's not prepared, but hey, you go for it. You're a man of challenge.
It's always good with a chat. No, I would tell them that wave energy is a major contributor to the green transition, to getting on the pathway of 1.5 degrees. And it has shown that the potential is there. Several studies have shown that the potential is there. We need them, and we need the politicians to help making the legislation and the frameworks to get the funding in place, not only from governments, but also from private investors. Make it attractive for private investors to invest in the green transition. And there's a huge upskill still to be made in wave energy and ocean energy in general. So I would highly encourage you, all of them, to invest time and hopefully also money in getting wave energy out there, as the world needs it. We all need it.
Excellent. I'm sure they will have heard about you, right? So who knows? You may get a phone call.
Good.
So, Emil, that was a terrific presentation. So, as I say, now people know about the technology that you are developing. They could see, like me, how simple and yet very effective it looks like, and we can't wait to see the first pilot. I know you're in Gran Canaria to work on that, but we want to see that in more places, and hopefully as well in some places as well in Africa. So thank you very much for your time today. And I'm sure you and I will have the chance again to work together and to talk more about this fantastic technology in this sector. So thank you for that.
Thank you very much.
Okay, excellent. So I'm hoping that you've had a chance to listen carefully to what Emil was saying, what Wave Piston is developing, and it's fantastic. So there may be some other technologies, certainly, but definitely theirs is, for me, hold some strong interest. I hold some strong interest there, and I believe that they may be one of the winners. Yeah. So wave power as a renewable energy source, it remains full of promise, but clearly we're not exploiting that enough. It's underexploited when you compare that to other renewables so far, right? But they have compelling economics and also sustainability credential, right? So with the type of breakthrough technology, like for example, Wave Piston is developing, I'm sure they will have their day in the sun and it will arrive finally, I'm sure. So I want to thank one more time here, Emil, so the Chief Commercial Officer of Wave Piston, for his invaluable insight that he shared with us today. So regarding the tremendous promise that is held by Wave Energy and Wave Piston specifically, as we transition rapidly towards a clean energy future globally. So we're definitely very excited to track the future progress, unlocking the enormous latent power contained within the ocean wave. So again, that was very terrific expert call. We're not done yet. I'm sure there's going to be a lot more that you will discover no later than tomorrow. So thank you very much for following us, listening to us, and encouraging us. And then I'll see you again tomorrow.